Yeah, my name is Gaurav Chauhan. I'm working as a professor in Department of Mechatronics and Biomedical Engineering. I'm working with basically nanomaterials, nanomedicine, biomaterials, tissue engineering, and biosensors. So basically, this all comes under a big umbrella of nanotechnology for healthcare. So we are working in a project related to tissue engineering applications with smart biomaterials. These biomaterials are made of nanofibers and with all the additives which are required for cells to grow. And basically in this project we are working to regrow a bone defect using stem cells from umbilical cords. And these stem cells are provided the environment with these scaffolds, the nanomaterial scaffold, to grow into the osteoblasts, the bone cells, and the future thing which we are now looking for is the smart properties of these materials, which include the physioelectric properties, so that we don't require multiple growth factors inside the human, you can say tissues to regrow the bone. Because they have several side effects in general. The another project we are working is in the industry of biosensors and point-of-care diagnostics. I am particularly working on hybrid biotransducers, where we are working with two-dimensional and one-dimensional biotransducers have the capability to attach with small biomolecules in a very rugged way using a gold-based chemistry. So these transducers will help us in defining the new generation of biosensors, which can help us in diagnosing the critical diseases like cancer in the biofluids like tear, blood, as well as saliva. But any new molecule will require almost like 15 years to come into the market to get it accepted as a drug. So this is a big time, it's a huge time, and it also requires a huge amount of money, around billions of dollars. So in order to come up with a new solution, we can actually deliver those inefficient drugs which somehow fails to come into the market by using these smart nanocarriers. This particular terminology is called as repurposing of the drugs using nanomaterials. And that's something which struck my mind, and I started working on it. And there are many new avenues which we can actually achieve with these kind of technologies, which probably like getting more efficient cancer targeting. So right now I'm working with glioblastoma, which is a brain tumor targeting, which is a very dangerous disease. And using these efficient nanomaterials, nanoparticles, we can actually find a solution. We are very close to find a solution regarding that. Well, CIDiTec and engineering school, they are providing us all the basic facilities to run such projects. And we are getting very good students from this department as well. The most important thing which I want to mention here is the freedom of collaborating with the international university around the world, and the freedom of expressing any idea. So because you need these bold ideas in order to commence such projects. So yeah, we have people in CIDiTec as well as in engineering department, which are quite open to listen our ideas and provide us all the backup to commence such projects. Moreover, we have excellent students here, which are helping us to define these projects from a very different point of view. I want to mention that I was working with a physics student in a medicine project. So there we can get the interaction of ideas from different departments, which is very useful in current, you can say, industrial solutions.